From this point onwards, things are going to start to get more interesting. We are going to talk about the data modifiers. So let me show you what I'm going to do now. I'm going to use the color mapper to do something very specific, to change the color of a single particle. Let's create a basic emitter, and let's go to the emission mode and shoot only one particle. That's it. I'm going to set my emitter size to 000 just to make it a point. And if I press play, you will see one particle is just going to start moving that way. Now, this is a bit too small, and my timeline doesn't have enough frames. I'm going to go to my particle group, go to the Draw tab, and let me increase the radius to 4 so we can see it. So rewind, and you can see the particle. Let me zoom in here. Excellent. So this is just a particle that is traveling on the z-axis. The color I want this particle to be originally, let me rewind, I'm going to go to the basic emitter, and that color is set in the properties. Go to the color tab, just twirl it down, and use a constant color. And I'm going to set this to red, 100% fully saturated red. So now my particle is going to be red. Excellent. What I want to do now is when the particle reaches approximately 60 frames of age, I want it to start changing color. And the way I'm going to do this is using a color mapper. So let me add a color mapper, and let's make it a child of the particle group. Now, it wouldn't make a difference in this particular setup because we only have one particle and one particle group. But this is a good habit you need to start developing, just in case you add other groups further down the line and you forget which one applies to which. So it's good to keep any modifiers that apply only to certain groups as children of those groups. What this color mapper is going to do is the following. It's going to use a property as the source, and that property is going to be the age of the particle. When the particle reaches an age of 60 frames, because that's the frame number, the 2-second lifetime mark, and up until it becomes 3 seconds old, then I want these colors to map to this particle, and after 90 frames, it's going to continue with the last color over here. This is what it's saying. It's very simple. Again, take the age of the particle. When it reaches 60 and all the way to 90 frames, so from 2 seconds to 3 seconds of its age, I want you to just go through this gradient and change the color until at 90 frames it's blue, and then it's going to remain blue. Let's see if that works. Rewind, press play, and it's going to change color, and now it's blue. So we are mapping a particular property, one of all these properties, to a particular other parameter, which the color mapper allows us to do that with a gradient or various other things. It has noise and so forth. And we can use fields, and there's a lot of stuff we can do to map these things. Now, another thing I can do is I don't want the age to map to a color. I want the position z. So as the particle moves in z direction, depending on the value of its z position, we can change this gradient. So just go to property and find position. And when we have these sorts of properties that have many components, you can select the x, the y, the z, the magnitude of the position, so how far away it is from the origin of the emitter, or the dot product, and this is for more fancy stuff. In this particular case, because it's moving in the z, whether we use magnitude or z, it's the same thing. I'm going to use z. And now our unit has changed from frames to centimeters. So from 60 to 90 centimeters, the color is going to go from red all the way through the gradient out to blue. So let me rewind, press play, and you will see, there you go. That was very, very quick. So let me set this to 500. So as you can see, it's changing color, and approximately 500 centimeters from the origin, which I think is over here, it turns to blue, and then it continues its life. Now, the great thing about this is that it doesn't matter how many particles you have or where they are going. And let me show you exactly what I mean here. I am going to change my basic emitter to emit from a sphere. I'm going to make this sphere 20 and 20 and 20, and I'm going to shoot more than one particles. I'm going to shoot 1,000 particles per second. Rewind, press play, and watch this. Only the particles that are moving in the Z direction are changing color, and they're changing color depending on how much they are moving in the Z direction. So now you can see some interesting things happening, and it's a good opportunity to show you the difference between the Z position, which is in one direction, or the magnitude. So I'm going to set this to magnitude, leave all the other parameters the same, and what's going to happen here is that particles that are away from where they were generated, 60 centimeters up to 500 centimeters, are going to use this gradient. So we're going to see a radial change of color. Red, and then we go into yellows, and then we go into the blues. And what the color you see here is not the override color. We haven't used the viewport override. This is the color that the particles are going to use to render. So if I want to make this a bit more fancy, let's just create a turbulence, let's change the parameters to something, and let's go to our basic emitter and say we want to go nuts and generate a million. Is it a minute? 100? Nope, I want to make it a million. A million per second, and press play, and we're getting all these particles, and you can go and render them. Excellent. I'm going to leave it as it is. I'm going to pull up my Redshift layout and press start, and you will see the colors of the particles appear in your render view. There they are, and we have this nice colorful particle simulation.